So today we're going to look at a thing called Cpctc, which I know is a real mouthful, but if you just remember the important parts of it, the actual words behind it, the corresponding parts of congruent triangles are congruent. So what this means is if you start with congruent triangles, then the corresponding parts, the things that match up, the sides and the angles, these are going to be congruent to each other as well, which makes perfect sense. If you have two triangles that are the same, then the pieces that match up are also the same. So in order to do this, the first thing you need is to actually prove that two triangles are congruent, because you can only use Cpctc if you have these CTs, the congruent triangles. So first you have to prove that the triangles are congruent before you can even think about using this as a reason in your proof. And Cpctc is used to prove additional sides and or angles are congruent. So you're going to need some sides and angles just to prove that the triangles are congruent in the first place. But then after you know the triangles are congruent, you can get the other sides and angles that you didn't already use to prove the triangle is congruent. And you can just prove that those are congruent to each other. So let's look at an example. So in this ever so slightly blurry example that apparently has been passed on for far too long and maybe needs a refresh, you see that PR bisects angle QPS. Oh, look, that's helpful. And it bisects angle QRS. Look, wow, congruence, crazy. We have to prove that PQ is congruent to PS. So first, let's go with the given information. Okay, got that. PR bisects angle QPS and angle QRS. So let's look at angle QPS first and what it means that it bisects. So since PR bisects QPS, that means that these angles right here must be congruent to each other. So we now know that angle QPR, so for all of you second division soccer fans out there, Queens Park Rangers, is congruent to angle SPR. So this angle and this angle congruent to each other because PR bisects angle QPS. So now, if we look at the other angle it bisects, angle QRS, we get that these angles are congruent to each other. So we have that angle QRP is congruent to angle SRP because PR bisects angle QRS, cuts this angle in half. Now, we're trying to prove that two sides are congruent, and based on the diagram, I have a hard time figuring out how these sides are actually congruent. So one thing we can think of, and it is the heading of this slide, so maybe that should be a hint, we should probably think about proving triangles congruent first. If we prove this triangle congruent to this triangle, then all the pieces, the corresponding parts, like this, also have to be congruent. So one way you can prove this triangle congruent right here, I'm looking at PR. They share this side. So we can say that PR is congruent to PR by the reflexive property. So now, if you look at this diagram, we have an angle, a side, and an angle here. That's enough to prove these triangles congruent. So we write that triangle PQR is congruent to triangle PSR by angle side angle. Now the last step, we're almost there. We know that these two triangles are congruent. That means the corresponding parts of the triangles are congruent, which means that PQ has to be congruent to PS because those correspond to each other on the triangles. So let's write that and we're done. So we just write that PQ is congruent to PS by Cpctc. So Cpctc is always a reason, and it's always a reason used after you prove triangles congruent.